Hello everyone, and welcome to the channel. Today we're going on an extraordinary journey, not to the well-known wonders of the cosmos, but to its most mysterious and mind-bending corners. We all know about black holes and distant galaxies, but what about the secrets tucked away in the shadows of the universe? The facts that science books rarely mention, and that only the most dedicated astronomers and physicists get to explore. Fact 1. The cosmic scent of space. We've all been told that space is a complete vacuum, silent, odorless, and utterly devoid of everything. That's true in a sense. There's no air for sound or scent to travel through. Yet, ask any astronaut who has spent time on the International Space Station what space smells like, and they'll give you a surprisingly consistent answer. A mix of seared steak, hot metal, and welding fumes. So where does this bizarre scent come from? It's not a smell that exists in the vacuum itself. Instead, it's a residual odor that clings to the spacesuits and equipment brought back into the pressurized environment of the space station. It's the physical manifestation of what's out there. The primary culprits are polycyclic aromatic hydrocarbons, PAHs, complex organic molecules that are incredibly common throughout the universe. These are the same molecules that are found on Earth in everything from exhaust fumes to charred foods. These PAHs are everywhere, in nebulae, interstellar clouds, and even the dust between stars. When a spacecraft or an astronaut's suit is exposed to the vacuum, these molecules settle on the surface. When they re-enter the pressurized cabin, the sudden presence of air causes the molecules to detach and become airborne, releasing that distinct, metallic, almost savory scent. It's a fascinating reminder that even in the vast nothingness of space, the universe is filled with tangible aromatic compounds. It tells us that the building blocks of life, and a lot of other things, are not just scattered randomly, but are actively floating around, ready to settle on anything that passes by. This is not just a quirky fact. It's a direct sensory connection to the chemical reality of our cosmic environment, proving that space might not be empty after all, just subtly aromatic. Fact 2. A planet made of diamond. You've heard of planets of gas, rock, and ice, but what about a planet made of pure diamond? Astronomers have discovered a super-Earth known as 55 Cancri E, orbiting its star so closely that a year on this world lasts only 18 hours. This blistering proximity means the surface temperature can reach over 4,000 degrees Fahrenheit, hot enough to melt rock. But the truly amazing part is its composition. Scientists believe that 55 Cancri E is a carbon-rich world. Unlike our Earth, which has a relatively low carbon content, this planet's star has a much higher ratio of carbon to oxygen. This has led to the theory that the planet itself is composed of vast amounts of carbon. Given the extreme pressure and heat deep within its core, that carbon could be transformed into a diamond. In fact, some researchers speculate that up to a third of the planet's mass could be in the form of diamond, with a thick layer of graphite on top. To put that into perspective, imagine a planet twice the size of Earth, with a surface so exotic it would make a science fiction writer blush. The discovery of 55 Cancri E challenged our understanding of planet formation. We used to assume that rocky planets, like our own, would form in a similar way and from similar materials. But this diamond planet proves that the chemistry of a star can have a profound impact on the types of planets that form around it. It suggests a universe filled with exotic worlds, where the very laws of geology and material science are shaped by the abundance of different elements. This isn't just a hypothetical scenario, it's a real exoplanet, a sparkling jewel in our galactic neighborhood, reminding us that the universe is far more diverse and strange than we ever imagined. Fact 3. The cosmic water reservoir. When we think of water in space, we usually think of liquid oceans on distant moons or the icy poles of Mars. But astronomers have made a jaw-dropping discovery that puts our humble oceans to shame. They've found a gigantic cloud of water vapor, yes, vapor, that is so vast it contains 140 trillion times the amount of water found in all of Earth's oceans combined. This colossal reservoir of water is located about 12 billion light-years away, surrounding a monstrous black hole called a quasar. Quasars are incredibly bright galactic nuclei, fueled by supermassive black holes that consume vast amounts of matter. As matter swirls into the black hole, it heats up to incredible temperatures, releasing enormous amounts of energy. This particular quasar, named APM 08279-5255, is so powerful that it's heating a vast cloud of gas and dust around it. Scientists were shocked to find that this cloud is almost entirely made of water vapor. The existence of this water cloud is a game changer. It's the largest and most distant reservoir of water ever found, and it's a huge clue about the early universe. Its presence tells us that water, a key ingredient for life as we know it, was abundant even in the earliest epochs of the cosmos. This means the building blocks of life were not a late addition to the universe. They were present from almost the very beginning. While we can't exactly bottle this water and bring it home, its discovery proves that water is one of the most common molecules in the universe, far more prevalent than we once thought. Fact 4. The Great Attractor. For decades, astronomers noticed something strange. The Milky Way and a bunch of other galaxies in our galactic neighborhood seem to be moving in a specific direction at incredible speeds, about 1.4 million miles per hour, towards a single mysterious point in space. This gravitational anomaly became known as the Great Attractor. What is it? The simplest answer is that we don't know for sure. It's a massive gravitational force, so powerful it's pulling hundreds of thousands of galaxies towards it, including our own. The problem is, it's located in the zone of avoidance, a part of the sky that's obscured from our view by the dense dust and gas of our own Milky Way galaxy. This makes it incredibly difficult to observe and study. Early theories suggested it might be a supercluster of galaxies, a collection of thousands of galaxies bound by gravity, with a combined mass of tens of thousands of times the Milky Way. Recent research using infrared telescopes that can see through the dust has revealed that the Great Attractor is likely part of an even larger structure known as the Laniakea supercluster. Our local group of galaxies is on the edge of this vast cosmic web, and the gravity from this huge structure is what's pulling us in. The Great Attractor is essentially the heart of this supercluster, and we're just a tiny piece of the greater cosmic flow. It's a humbling reminder that our galaxy is not stationary. It's part of a massive cosmic current, drifting towards a destination we can barely comprehend. The mystery isn't just in what's pulling us, but in the unseen forces that shape the destiny of every galaxy in the observable universe. Fact 5. The loneliness of rogue planets. Imagine a planet, a world of rock, ice, or gas, floating alone in the vast, cold darkness of interstellar space with no star to call home. These are rogue planets, or free-floating planets, and they are believed to be more common than stars in our galaxy. How does a planet end up so isolated? Most rogue planets are born from the chaotic nurseries of young solar systems. During the early stages of planetary formation, when planets are jostling for position, a close gravitational encounter with a much larger gas giant can be enough to hurl a smaller planet out of its orbit and into the cold emptiness of interstellar space. These planets are essentially cosmic orphans, ejected from their homes with such force that they can never return. Because they don't orbit a star, they're incredibly difficult to detect. They don't produce their own light, and they're not illuminated by a parent star. Astronomers can only find them using a technique called microlensing, where the planet's gravity briefly magnifies the light from a background star. This creates a temporary burst of brightness, that can be detected by telescopes. While we have only confirmed a handful of these rogue planets so far, statistical models suggest that there could be hundreds of billions of them in our galaxy alone. They are cold, dark worlds with no prospect of warmth or light, yet they still hold the potential for life. Some scientists speculate that life could exist on rogue planets in subsurface oceans, warmed by geothermal energy from the planet's core. Conclusion. We've traveled from the smell of space to the loneliest planets, from diamond worlds to cosmic lighthouses, and we've only scratched the surface. The more we learn about the cosmos, the more we realize how much we don't know. It's a place of immense beauty and terrifying power, and it's a privilege to be a part of it. I hope you enjoyed this journey into the unknown. If you did, please leave a like and subscribe for more mind-bending space content. Let me know in the comments which of these facts you found the most surprising. Until next time, keep looking up.